Hi everyone. This is going to be our look at trigonal planar. We're going to have this shape called trigonal planar when our central atom has no lone pairs and 3 bond locations. This time I have 2 different examples because a double bond or a triple bond counts as 1 location. We need to explore that with our trigonal planar shape. The first one is BH3. Boron trihydride, BH3. Let's start off with the Lewis diagram. Looks something like that. Now I need to find the central atom. The boron is in the middle. Boron, with only 3 valence electrons, does not have a lone pair. There's nothing there. We need to be careful. Nitrogen and phosphorus also have 3 bonding electrons. However, they do have a lone pair, so we need to be conscious of that. Boron, no lone pairs. And here's 3 single bonds. That's no lone pairs, 3 bond locations. So I need to draw a trigonal planar shape. Because it's planar, all of the atoms are going to be in the same plane. So we're going to use solid lines. It's a little bit picky now. This is the pickiest one of them all. We need to be a little bit conscious of how we draw it. Notice how I started off the same way, H and then B horizontally. Now, on the back side, I'm going to give it a V shape. The idea here is each of these hydrogens are the same distance away from each other. We don't want it to look too square. There is a subtle difference between this Lewis diagram, which has these right angles, and here the trigonal planar shape, which looks like more of a star or something like that. Trigonal planar. Here's a second example, just to emphasize the idea that a double bond counts as 1 location. I have CH2O. I'm going to start off by doing the Lewis structure. Here we have the multiple bond. There's a double bond in between the carbon and the oxygen. The oxygen, as a matter of fact, has 2 lone pairs. Once I have the Lewis structure, I need to find the central atom. Here, I might accidentally feel tempted to focus on the oxygen because we have seen other cases where oxygen is the central atom, like in water. But here, the oxygen's out on the end. It's not in between something. The oxygen is only attached to the carbon. A central atom is an atom that's attached to 2 other things. It has to be in between some stuff to count as central. So here, carbon is the only central atom in this molecule. Carbon does not have lone pairs. So we have the 0 lone pairs. And there are, yes, a total of 4 bonds, but the double bond counts as 1 location. So this carbon has 0 lone pairs and 3 bond locations. 0 lone pairs and 3 bond locations puts us in the trigonal planar shape. I'm going to follow the same procedure that I did with the other ones. I started off horizontally. That part is identical. Here I'm going to do the same thing. H to C. Now instead of making the backside look very square with right angles, I'm going to make it into a V. I'm going to spread it all out and increase the angle size. This, however, is still a double bond. When I'm doing stereochemical structures, if there's a double bond or a triple bond, I still have to show it. And now here's the other hydrogen. When we're doing trigonal planar, all of the bonds are solid lines. We're not going to see any dotted lines or any wedge-shaped lines. This is our first kind of shape where the possibility existed for a double bond counting as 1 location, and that's a thing to be conscious of. For sure, if we have single bonds around boron, but watch out for those times where you have a carbon with a double and 2 singles, that's also going to fall into this category. And I hope that helps.